The question for this topic asks about the amount of energy needed to break a carbon-carbon single bond. In order to break a carbon-carbon single bond, you need 355 kilojoules of energy for each mole of carbon-carbon single bonds. So, if I've got green light with a wavelength of 550 nanometers, does that wavelength have enough energy to break the carbon-carbon bond? After you give your answer, explain using calculations. Well, the brief answer is no, there is not enough energy. And there are two ways to show this. They're basically variations on a theme. So let's start with the first method. 355 kilojoules per mole is 355,000 joules per mole. Divide that by the number of molecules in a mole, and you get 5.90 times 10 to the minus 19th joules per molecule, and that's the energy needed to break one bond. We know we have a wavelength of 550 nanometers, which is 550 times 10 to the minus 9th meters. We're going to utilize our C equals lambda nu equation. We plug in the values, we solve to get the frequency, and we get a frequency of 5.45 times 10 to the 14th per second. Now we switch to our energy equation, plug in the values, and we get 3.61 times 10 to the 19th joules per photon available. Since 3.61 times 10 to the 19th joules is less than 5.90 times 10 to the minus 19th joules, this wavelength of light cannot break a carbon-carbon bond, QED. Method 2. Start with converting nanometers to meters. Back to our C equals lambda nu equation. Plug in the values. Solve for frequency. You get 5.45 times 10 to the 14th per second for the frequency of this wavelength of green light. Now we look at the energy. We plug in the value and once again get 3.61 times 10 to the minus 19th joules per photon. Multiply that value by 6.022 times 10 to the 23rd photons per mole. That'll give us the number of joules per mole. That's 217,322, which is 217 kilojoules per mole. As is obvious, 217 kilojoules per mole is less than 355 kilojoules per mole, and the 355 kilojoules per mole is the minimum amount of energy to break a carbon-carbon single bond. So this wavelength of light cannot break a carbon-carbon bond, QED.